In any discussion of fifth-generation fighters, the conversation almost invariably gravitates towards two central concepts: all-aspect stealth and integrated network warfare. These principles have defined the developmental trajectory of Western air power for decades. Yet, when we turn our attention to Russia's Su-57, we find a machine that deliberately deviates from this established script. It's not an attempt to replicate a Western model, but a reflection of a fundamentally different operational philosophy, one forged from a unique set of strategic priorities and industrial realities. The Su-57, known by its NATO reporting name, Felon, was conceived as the successor to Russia's formidable but aging fleet of Su-27 and MiG-29 family aircraft. However, the program's objective was never a simple pursuit of low observability at any cost. Instead, it aimed to create a balanced platform that would preserve the traditional strengths of Russian fighter design: exceptional agility, heavy firepower, and robust survivability, while integrating select fifth-generation technologies. This approach represents an evolutionary step, not a revolutionary break from the past, producing an aircraft that is arguably more of a superflanker than a direct counterpart to its Western peers. One of the Su-57's most striking and defining characteristics is its extreme maneuverability. This is not just a secondary feature, it is a core tenet of its design. By combining advanced aerodynamic shaping with powerful three-dimensional thrust vectoring engines, the aircraft can perform breathtaking post-stall maneuvers, effectively pointing its nose and weapon systems independently of its direction of travel. This capability gives the pilot a decisive edge in a visual-range, close-quarters dogfight, a scenario that Russian air doctrine, unlike some of its counterparts, has never fully discounted. The prominent leading-edge route extensions and large control surfaces are clear physical testaments to this prioritization of kinematic performance over absolute stealth. This leads to the most debated aspect of the Su-57, its approach to stealth, more accurately radar cross-section reduction. The aircraft incorporates key shaping features, such as aligned panel edges and internal weapons bays, to reduce its frontal radar signature. However, a detailed examination reveals numerous compromises. The engine inlets lack the complex serpentine ducts found on aircraft like the F-22 or F-35, and certain elements of the airframe, particularly from the side and rear, are not optimized for low observability. This was a deliberate trade-off. By accepting a higher degree of detectability, designers were able to retain superior aerodynamic performance, a larger weapons payload, and a more robust, maintainable airframe, all while managing the immense cost and complexity associated with achieving very low observable status. To compensate for its less stealthy profile, the Su-57 is equipped with a sophisticated and distributed suite of sensors. Its NO36 Bielka radar system is not a single forward-facing unit but an integrated package featuring a main X-band AESA radar in the nose, smaller X-band radars in the wing's leading edges for side-looking capability, and L-band arrays built into the wing slats. This multi-band, multi-directional system provides the pilot with exceptional situational awareness across a much wider field of view. The L-band radars in particular are theoretically more effective at detecting stealth aircraft at longer ranges, trading precision for early warning. This philosophy suggests a reliance on seeing the opponent from unexpected angles and frequencies, rather than simply remaining unseen. Despite these innovative design choices, the Su-57 program is beset by significant challenges that directly impact its operational effectiveness. Production has been slow, with only a small number of serial aircraft delivered to the Russian aerospace forces. This limited inventory prevents the development of the tactics, training, and logistical support required for a mature combat ecosystem. Furthermore, the aircraft is still awaiting its definitive ISDEL-I-30 engines, with current models flying on an interim power plant. Delays in avionics and software integration also mean that the aircraft's full potential, particularly its networking capabilities, remains a work in progress rather than a present-day reality. Ultimately, the Su-57 represents a compelling, alternative interpretation of what a fifth-generation fighter can be. It is not an asset built for large-scale, deeply integrated, stealth-dependent campaigns. Instead, it is a powerful air superiority platform that emphasizes pilot skill, kinematic dominance, and tactical independence. It is a machine designed to survive and fight in a contested environment where stealth may be compromised, relying on its agility, powerful sensors, and heavy armament to gain the upper hand. The Su-57 should not be judged by a single metric or directly compared within a framework it was never intended to fit. It is the product of a distinct school of thought shaped by specific strategic requirements, economic constraints, and a long-standing doctrinal emphasis on close-in air combat. It is an aircraft with a clear set of strengths and equally clear limitations, offering a fascinating and potent, yet fundamentally different, vision for the future of air power.